Good afternoon, everyone. Thank you for joining us for today's PowerTalk webinar hosted by ASCO Power Technologies. Today we'll be covering 2026 National Electrical Code changes that impact power transfer. And our speaker this afternoon is Robert DeBrody. Robert is the Director of Program Execution at ASCO Power Technology. His primary duties include understanding and developing opportunities to meet the demands of the latest customer applications and to ensure the ASCO transfer switch product line remains at the forefront of engineering and design. Robert has been with ASCO for 10 years and is currently acting as the product manager for the transfer switch product line. Before ASCO, he's held roles as VP of Engineering, Director of R&D, and Program Manager at some large industrial companies. Robert has an associate's degree in architectural design, a bachelor's degree in electrical engineering from Syracuse University, and a master's in engineering management from George Washington University. Robert is a professional engineer and has several patents. He's also served on an NFPA committee. So before we get started, just if you have any questions throughout the webinar, please put them in the chat or use the Q&A feature, and there'll be time at the end where Robert will answer your questions. All right, so Robert, take it away.
All right, thank you. Yeah, I'll do my best to answer questions. This is an opportunity to stump the presenter, so you guys pull out some good ones, I'm sure. Just to give you a brief overview. So today I want to talk about just understanding the code making process. We're going to get down to the electrical systems. We're going to talk a little bit about those sections of the National Electrical Code. And then, mostly the focus is going to be on backup power, power transfer, and changes to those specific areas. So let's dive into it. You already heard about me. You don't want to hear about that again. So again, we're going to talk about NFPA 70, most commonly referred to as the National Electrical Code. And I used to think of it as, oh, isn't this a burden on me as a designer that I have to follow the details in this code? But it's there for a good reason, and it's there to safeguard persons and property from electrical hazards, and really it's for my own good to follow this code because they may come up with some things that had not occurred to me as an engineer, and it protects me, it protects my company from liability. So NFPA codes are updated on a 3-year cycle or a 5-year cycle, depending upon the code. This one, specific one, is updated every 3 years. And in the process of determining what changes they were going to make to the 2026 code versus the 2023 code, they queried, you have an opportunity as anybody in the public to submit comments. There were over or close to 6,000 comments submitted on proposed changes to that code. So you can imagine these 18 code making panels would break up those almost 6,000 comments, and they would debate them and determine what ones they want to accept in whole or in part and what the wording changes should be. And lo and behold, on the 9th of September of this year, they released the 2026 version of the code. Now that the 2026 version is out, let's talk about the 2029 version, which is the next one out. I know I don't want to jump too far ahead, but it's important that we talk about this. On the 2029 version, as you can see this table on the left-hand side here, they're really looking at reformatting the code to make it easier to understand and to find things when you're looking up things. You can see some of the current chapters are going to be broken up into other chapters. There's going to be things that are moved from one chapter to another. So hopefully they'll be successful, and it will be a little bit easier to learn and to understand and to find the data you're looking for. So the reason I mention this is, you only have now, that even though the 2026 code has just been released, you have less than 6 months now to put your public comments into NFPA for changes to the 2029 code. You only have till April 9th to put in those comments and suggestions. So they'll take those in, and as you saw in the earlier slide, there was almost 4,000 of those comments. So they're going to take those 4,000 comments, which they'll probably get again this year before the April 9th, And then they'll ponder them for about a year and a couple months, and then they'll release the first draft report. And after that first draft report, then you get only a month and a half to comment on that first draft to say, no, I don't like the way you implemented this. I don't like the wording changes here, or whatever. So a very short time period there. And then they go away and they take those comments. And then after what, I think it's 8 months, they release the second draft report. And by the time that's done, that's pretty much cast in stone. There's very rarely are changes made after that second draft report is released. So if you're looking to make some suggestions or comments, or there's anything in the code that bothers you or concerns you, don't miss that timeline. Jump on in there and make some changes or suggestions. So let's look at what the current state adoption is for the NEC. And as you see on this chart, the light yellow are the states that are on the 2023 version. The purple shows the ones that are on the 2020 version, and poor Kansas and Indiana, they're still on the 2008 version of the NEC. They'll never catch up. And you may be thinking, all right, well, look, my state's on the 2020 version of the NEC. Why do I care about what's come out in the 2026 version? Well, as a designer, this is most of the stuff that's in there is good engineering practice. And as I mentioned before, just to protect you and protect your company, if there's something that's been implemented in the 2026 version, even though your state hasn't adopted it, it's probably a good idea for you to at least consider implementing it or exercising it. The cost may be minimal, and you also have to consider the ramifications of not doing what's in that code. So it's a good idea to keep up to date on what the changes are, suggested changes are. So there's thousands of changes to the code. I possibly can't do it all justice in an hour. So again, we're going to focus on specific area. I'm going to cover the stuff in green here on the screen. There's a couple more that I'm going to address, and I also included these ones that in other parts of the code that I thought were interesting and were important to be covered. And I should have enough time today to go over those two, just to point them out so you can look at them later during your leisure time. So let's dive in. There's 4 electrical systems that are defined in the NEC for backup power and power transfer, and that's where our focus is. So there's emergency systems, legally required standby systems, there's optional standby systems, and there's critical operations power systems, referred to as COPS. And the chart I show here just gives you a quick overview of how each one of those different electrical systems compare to each other and how they differ from each other. So they all address installation and operation. And you might look at the optional standby systems. Well, if they're optional, why are you telling me how to install it and operate it? Well, again, it's to be sure that it's done safely. So that's why it's addressed in the code, even if it is optional. For servicing, they don't address the optional standby systems because really you as the owner of that backup power source are responsible for following manufacturer's instructions. I'm sorry, I skipped over the column that said type. On type, what we're talking about is the backup power source. Is it a permanent power source or is it a temporary power source? For emergency systems and legally required standby systems, they require that to be a permanently installed backup power source on site. For optional, obviously, it's temporary or permanent, whatever you so choose to use. And for critical operations power systems, I think in most cases, you'll find that it's a permanent power source. There may be times where the time they give you to switch from normal power to backup power, power fails, is long enough that you could hook up a temporary power source. I think it's probably not the norm. And then the last thing on the chart is just that for critical operation power systems, they go into detail about talking about how you monitor and how that system would be controlled. So let's jump into the first one. I'm going to go through the 4 of these really quickly just to go a little bit deeper into them. So Article 700, emergency systems. These are systems where when normal power fails, you must automatically switch over to your alternate source of power within 10 seconds. And these are systems that are essential for safety to human life. And when you think about safety to human life, emergency systems, you think of hospitals. But look at the photograph here on the bottom right. You see a sports football stadium filled with people at night. And you can imagine, would there be any safety risk to the people in that stadium if the power went out? Yeah, there would be. So emergency systems also include anywhere where there's a large group, a number of people that are congregated into a single facility, hotels, theaters, casinos, um, sports arenas, things like that. And they're there just to power up emergency lighting, the elevators, the fire pumps, the communication systems. The next one down is legally required standby systems. And these are where interruption of power could create hazard or hamper firefighting operations or rescue operations. Um, Here they give you a little bit more time. On emergency systems, we saw that you only were given 10 seconds to switch over to that backup power. Here you're given 60 seconds because it's not quite so critical. And this is to power up things like sewage disposal, ventilation, smoke removal systems, and communication systems. Next one down is your optional standby systems. And again, these are ones that aren't required by the code to be permanent or mandatory or mandated. So it's things like your own home, gas stations, convenience stores, farms would have something like this. Um, and again, this one, you can use a temporary source or it can be a permanently mounted. In most cases, it's not a permanently mounted because they just don't have the space for it, or they don't want to spend the money to put in a permanent installation of backup power. So they may just have a generator in the storage room, and when power goes out, they'll wheel out that generator and connect it up. And again, the code goes in to tell you how to connect that up to make sure that the person connecting it up and you're not paralleling sources. So they'll put in some provisions and guidelines to make sure that it's done safely. And the last of the four is critical operation power systems, COPS. And this is for facilities or portions of facilities that are critical for maintaining public health and safety. They may be things for national security, ensuring the economy is sound and safe, and even business continuity. So it's things like the 911 call centers, it's emergency evacuation centers, police stations, fire stations, air traffic control centers, which we would all like to stay powered up. And again, it ensures that communication systems, signaling systems, HVAC systems, and alarm systems are operational. All right, so now I'm going to actually dive into the 2026 code. And the way each one of these slides is structured is I'll give you the article number, I'll tell you what it's called, what the name is, and then that first green box that you see up above just kind of tells you, my summary of the changes to the code and what I think the ramifications are for the industry. So here, I'm going to show you, I'll show you on the first, in the lower box here, what it was listed in 2023 and what 2026 shows. And for transfer switches, it's the same. There's no change has been made to that. And just to make sure that we're all on the same page here, a transfer switch is there to detect the loss of normal power and switch you over to your backup power source. It sends out the start signal, starts up that backup power source, and then switches you over. And while it's on that backup power system, it's constantly monitoring normal power so that when it comes back, it switches back automatically. So then down further, you see what was listed in 2023, and you see for the definition for a bypass isolation transfer switch, a lot of words, manual, automatic, non-automatic, and then it just kind of goes into details about what it's there to do. And then they abbreviate it. They condensed it down to just a few words, saying equipment that includes a transfer switch and a bypass isolation functionality. Well, now I think they left a little bit to your own imagination on what exactly that is. So I want to, if you look at the picture off to the right, this is a bypass isolation transfer switch. And really, it's just two transfer switches in the same enclosure, and they're working in parallel with each other. Or sorry, one is the backup to the other. so that if anything happened to that transfer switch, you can always bypass it. It's already connected up to both sources and the loads, so it's easy to bypass it and go one to the other. And then once you bypass it, you have the ability to test that transfer switch, and you have the ability to isolate it, as shown in this picture here, where you can actually pull out the complete transfer switch. You can perform maintenance on it. You can actually replace the whole transfer switch if you wanted to. So it's just a way to get around the permanent transfer switch in case there's a failure or it needed or it's down for services or even for testing. If NFPA 110 says that for emergency systems, you must test the transfer switch once a month, and you must test your generator once a month. So the easiest way to do that would be to bypass it and then test your transfer switch along with the generator. Hope that's all clear. I know I raced through that pretty quickly. So let's look at the first change here in 700.4F, which is a temporary source of power for servicing of the alternate source of power. So they changed some wording and they added some paragraphs to this. So instead of looking at this slide, let me jump down to the next slide, which shows you what the complete section article in the code states. So really, this is talking about the case where you have one alternate power source available on site. So I have a generator, a permanent generator on my site, and what they're worried about here is when that generator is down for service or repair, you don't want to be lost without any power. So what they're stating here is that if you have a single source of power, you will have an easy way to hook up a temporary source of power. It'll be permanent. It's got some safeguards on it to make sure that it doesn't parallel with anything. It's got, assurances that you're not going to be messing with any of the permanent wiring on the site. So I'm not going to read through each one of the 7 steps that have not changed in wording, but let's focus on the 3 that they actually added that are new. So they're saying if you hook up a temporary generator, they want to make sure it has an overcurrent protection device in it to protect the downstream equipment and cabling. So they want a circuit breaker in there with that temporary generator. Understandable. 9 talks about separately grounded systems. So they want to make sure that this temporary generator has that same type of switching of that ground terminal as the grounded terminal as the permanent source did. And the 10th one here talks about a section that they say will no longer apply. So let's jump back up. And down at the bottom of this slide, you can see what that section is that they say it shall not apply. And that's just telling you that the integrity of the wire, that start signal out to the generator, you don't have to monitor that if you're hooking up a temporary source. I guess it's kind of difficult to maintain that checking of those wires when you've gone from a permanent source to an alternate source. So it's understandable why they might say that you're exempt from enunciating and starting the generator if there's a break in that start signal cabling. Off to the right here, this is just an example of a product that would do this. You can see in the bottom left there is where you would hook up a temporary generator to the cam locks, and above that is the circuit breaker, and off to the right is the manual transfer switch that you would use to transfer you from the permanent source to the temporary power source. All right, let's go on to the next one. This one is Article 517 is an extension of Article 700. So 700 covers healthcare facilities. It covers, the things we talked about already, the theaters and the casinos. But 517 goes into more detail about healthcare facilities. They want to make sure that it's really clear exactly what's required for healthcare facilities. So basically, this is the same things that were listed in 700 about having a backup to your alternate power source, but it also tells you things like how big that temporary power source should be. They want to make sure it's the same size as the permanent power source. They want to make sure that it's marked with a phase rotation, which is a requirement out of 700. So it just kind of reiterates exactly what's saying. Oh, the other important thing is number 3 here. It actually tells you the parts of an emergency care healthcare facility that they want illuminated. It's the stairways, it's the elevators, it's the hallways. So it kind of gives you stricter, more defined clarification on exactly what they're looking for. This next one is pretty important too. I'm surprised to see this because this is the first time it's in here. Article 517, same article, just a different paragraph. It talks about facilities that have more than one backup power source. So let's say you have a casino that has 2 or 3 generators out there to supply the power needed for your emergency system. And what they're saying here is that if one of those systems goes down, sorry, this would be for a healthcare facility. If one of those generators goes down, you must have a way to replace that one generator with a temporary generator. So they're going beyond the one to multiple power sources and saying that you must have a way to get around it. And again, they go into more details about how this temporary generator will interact with the permanent generators that still may be online, making sure that they work in conjunction with each other, that there's no problems. And the temporary connection is sized to supply enough power that the largest generator on the site was supplying previously. So pretty interesting. And it's understandable. Microgrids, big thing. Talking about facilities here was where a casino may have a solar panel grid out in the back to supplement the power draws. And this just talks about, it's a paragraph that was already in there before, and they just added what I highlighted in yellow here, saying that if you have a microgrid system, which may be solar panels, it may be a fuel cell system, and maybe backup storage systems, and combined with a generator, they want to make sure that you're using a listed device. And what is a listed device? In this case, it's UL 3008, emergency interconnection equipment, which you see in the photograph here. Just making sure that when you're trying to jockey between these fuel sources that you're doing it safely. And you see the same revision or same type of wording and paragraph in 701, which is the legally required standby systems, the same as the for emergency systems. So I want to back up for a second and just talk about how things evolved in the NEC. It's never a clear path of one step forward. Sometimes the NEC is trying to catch up with other codes and standards that are out there. They're trying to catch up to what the industry is already doing and already implemented, and making sure it's done safely. And other times they're setting the course. They're ahead of everybody, saying, look, this is the way things should be done. And sometimes it's 2 steps forward and 1 step back. So let me give you a couple examples. So in 2014, was the first time that for critical operations power systems, they said if you have a single source of power, you will have connection for a temporary source of power. Great idea. They must have had a problem somewhere at some critical facility that the backup generator didn't work, and they had no way to connect up an alternate source of power, not an easy way to do it. So in 2017 is when they said, hey, that was such a great idea for cops, we ought to put it in there for emergency systems. So they did. So that's when it hit the standard for in 2017. The same type of thing happened with transfer switches. So in the 2020 code, under COPS, they said that, look, if you have a single transfer switch that's supplying power to your critical loads, and that transfer switch goes down, you have a single source of failure. The same way they addressed it with the generator, they said, look, I don't want that transfer switch to fail, and you have no way to get power around it to your loads that are so critical. So let's make sure that you put in a bypass isolation transfer switch to make sure that you can get around that transfer switch if it fails. So in 2023, they said, great idea for cops, we ought to put it in emergency systems. So they did that same thing. They put it in for emergency systems. And while they did that, they said, you know what, maybe we should change the wording. We don't want to isolate. The only way to get around that transfer switch is using a bypass isolation transfer switch. Maybe there's other ways. So let's put in the wording redundant transfer equipment. And they also said, well, we don't want to make this a burden on those some facilities that they have to use a bypass switch in all cases. Let's say that if there's certain periods of time where that building is unoccupied and you can safely get around that transfer switch while it's being serviced, then it's not a problem. You don't have to implement this. So they put in some exceptions, which we'll go over in a slide or two later. And now in this newest version of the code, they got rid of the term redundant transfer equipment because it wasn't defined anywhere. Understandably, why it just caused more confusion than it was worth, so they got rid of it altogether. They changed in emergency systems what types of facilities are exempt, which we'll talk about later. And in legally required systems, they said, you know what, if it was so important for cops and it was so important for emergency systems, maybe it's something we should put in here for legally required standby systems. And then they said, well, we don't want to mandate it. Let's just tell them that we're giving them permission to use a bypass isolation transfer switch, which is kind of funny. So we'll talk a little bit about that in the coming slides. But that just kind of gives you a feel for how things may evolve here with the NEC. So let's look at the first one. So the first one is, this is the emergency systems, and this is the most recent changes that were made to that thing. Let me see. Yeah, okay. It's better if I mentioned they rewrote the term redundant transfer equipment. They added some wording, they changed some wording, a couple paragraphs. So let's actually look at the changes. I'll compare it to what it was in 2023 and what it is in 2026. So as you see up above, they say means shall be permitted to bypass and isolate the transfer switch equipment. That was encompassed everywhere. You can always use a bypass switch. And then they added that redundant transfer switch equipment paragraph. So they got rid of both of those, and they said, okay, let's put it all in a more concise way down here and describe it a little bit differently. So they say for occupancies listed here. So I'll jump back and show you what it's actually down further. We'll talk about what specific occupancies they're talking about here. So that's where they're putting their exception. Up above in 2023, you see these are the 4 exceptions they gave for when you don't necessarily have to have that redundant or bypass isolation transfer switch. The other thing that changed here was they said that if you have a bypass switch, the wording in paragraph 1 down below, they say they want to make sure you're maintaining continuity of power so that when you're going from the transfer switch to the backup alternate bypass switch, that you're not losing power when you do that. They want to make sure you can transfer between the two without losing power. There's manufacturers out there that sell bypass isolation transfer switches. When you switch from one to the other, you lose power even for a few seconds. They don't want that to happen. They want to make sure that there's a continuity of power between the two when you switch from one to the other. And number 2, it's a new paragraph, but it really means just make sure that when you isolate that transfer switch, you can completely isolate it from everything and actually pull it out and repair it and maintain it, whatever you have to do. So let me go down and, sorry about that. Let me go down and let's talk about that paragraph that they referred to now. Instead of the exceptions that they had before, these are the new exceptions. So it's not a new paragraph. It's been in the code for a while, and it's really in a section of the code that talks about fire rating. It talks about mandating a 2-hour fire rating, and this is what you have to do to make sure that you can at least survive a fire for 2 hours. And this is how it was described in that section. It says assemblies with occupancies of not less than 1,000 people. So what they're saying now by using this paragraph for bypass switches, they're saying that if you have an occupancy of 998 people, you don't have to have a bypass isolation transfer switch. So it makes you kind of think, well, why? Why is 900 people okay to lose power to, and not have that mandated in that case? And the second one really tells you what this paragraph is all about. It says that if it's less than 75 feet above the access from a fire department vehicle, you would have to have a bypass switch, but under 75 feet, you don't. Okay, that doesn't make much sense. And educational occupancies of less than 300 people. So if you have 250 people in an educational facility, you don't have to have a backup to your transfer switch. Really hard to understand. So it isn't just me that thought that. both UL and NEMA said the same thing. They said this really makes no sense. So there's this thing called a TIA, a tentative interim amendment. So we know that this code is updated every 3 years, and if you feel that there's something important enough to implement a change before that 3 year period, you can submit a TIA, and if NFPA accepts that TIA, they will list it on the NFPA site as these are amendments to the current code that's out there, so you don't have to wait that 3 years. So anyway, UL and NFPA both agreed that what they've done here is not a good idea, and it puts people at risk, and they really should make a change to it. So I'm not sure if this TIA has been submitted yet, but I know it will be, and most likely it will be accepted and listed there as a change to the code, hopefully. This is critical operations power system had the same type of wording change. I'm not going to go over it in detail. Here's how the paragraphs were before. As you see, there were under the redundant transfer equipment, there were no exceptions. It just said that if you had a single transfer switch supplying all of your critical loads, you must have a way to get around it by using a bypass switch. So same wording that we saw previously. And this is what happened in legally required standby systems. They're not requiring the bypass isolation transfer switch, but they're permitting the use of it. And the funny thing is, let's look at what it said before. So this is the paragraph in 2023. It says, means to bypass isolate a transfer switch shall be permitted. Well, okay, they're just giving you permission to use a bypass switch. But now, with the change that they made in 2026 here, they're saying, okay, if your legally required standby loads are supplied by a single feeder, you can use a bypass switch. Okay, and this is how you do it safely. I think that's really what they were trying to do. They're trying to make sure that you're going to do it safely. So they're providing some guidelines in here on how you do that. But sadly, by removing that paragraph that was in 2023, they're in essence saying, which they didn't mean to do, they're in essence saying the only time, or implying the only time, if you're going to read this at the literal sense, that the only time you can use a bypass isolation switch now is when you have your standby load supplied by a single feeder, which is not what they intended. So I wouldn't be surprised if a TIA came out here just clarifying that you can use a bypass switch anywhere. But I think the industry already understands. Oh, and by the way, and I failed to mention this before, is that even though 2020 was the first time a provision like this appeared in the code saying that bypass switches are mandated to be used in a critical operations power system, for over 40 years, you can look back 40 years, and hospitals, there's no hospitals built in the last 40 years that don't utilize a bypass isolation transfer switch. So this was the code catching up to what industry has already known, that you got to have a way to get around that transfer switch if it fails. Something that's new in the 2026 code is they defined power control systems. Now, inside the body of the code in the past, this was defined. PCSs were defined, but now they're actually bringing it out to the definition sections of the code, saying that it's equipment that monitors and controls. It's a part of an energy management system. And that's where it was buried before, but now they're going to be giving it a little bit more prominence and describing the difference between a single source, where a PCS would only be turning on and off loads, or a multi-source, where a PCS system would be involved in paralleling those sources of power, as well as perhaps turning on and off loads to match up. And there's another paragraph, 705, as I list down here at the bottom, 705.13, which was renamed from energy management system to a power control system. And I didn't put all these paragraphs in here. All I do was take the headings of these few paragraphs, but this is not, I wouldn't say it's new content, but it's content that was renamed from energy management system to PCS and defines how a PCS should work. There may be a few slight wording changes within these paragraphs, but in essence, it just talks about how the PCS monitors and controls and how it responds to a malfunction and how it's marked. So if you're involved with the PCS, I suggest you look at these sections to see if anything really has changed. Paragraph 702. 702 is optional standby systems, automatic load connection. If you look off to the right here, here's a load management system that's designed to shed loads. It works with a PCS systems or with an energy management system. So the changes here really just kind of separate what an energy management system is and what a PCS does. So I think on the next slide, go to that. And it just shows you the two wordings here. So it's saying here that if the connection as load is automatic, an optional standby system shall comply with the following paragraphs. So your options are to comply with 130.30 or 130.70. So here's what those paragraphs say, and I apologize for jumping back and forth. And it talks about a load management system, which really describes the shedding of load to match the incoming power and what the criteria is to shed load and what things need load all the time. And then 130.70, this is brand new stuff. It just talks a little bit more about how a PCS system would work. Talks about how it's controlling the amperages and making sure that it's married up properly with the load as well as the sources. Turning off generators if they're not needed, if the demand isn't there, and then turning them back on if the demand is there. Now we get a little bit into some other things that aren't directly tied to alternating power and backup power. This I thought was pretty interesting because I guess formerly in the 2023 code they decided, or someone had determined, that a 2-inch coating of concrete was enough to give you a 2-hour fire rating. But now they're saying, no, they're not so sure that that's true. So what they're saying now is if you're going to encase some conduit and wiring within concrete, it's not good enough just to get a 2-inch coating. They want it from every surface, but they also want a licensed professional engineer to say, yeah, this will ensure you have a 2-hour fire rating. If you don't want to do that, then you have to go down to number 6 here, and you have to encase that conduit or wiring within 5 inches of concrete, which, funny enough, is if you look at the photograph off to the right here, this looks like conduit covered in 5 inches of concrete, and they got the upper portion here all formed up to pour in more concrete to cover the vertical conduit that's going up. So pretty interesting, pretty important. So this just shows you what that complete paragraph had in it. It had the existing 4 paragraphs, and then the 5th one that was altered, and then the 6th one that was added. Arc flash marking, another big change here. Previously, in the 2023 code, it said that arc flash marking is required for everything over 1,000 amps. But now they're saying for all non-dwellings, unit services and feeder equipment will have arc flash marking. And a typical label is shown off here on the right. That's where you show the nominal voltage, the arc flash boundary, the incident energy, and when that assessment was done. So big change, big change. So 1,000 amps and above before, but now it's under, just trying to safeguard personnel. Another big change is on surge protective devices. Now they've expanded to areas that are similar to a bedroom. And this again, I think, is the NEC catching up. I think the building code already stated something like this. And they're just talking about areas that are designated sleeping quarters in fire stations, police stations, ambulance stations, and so on. So we're just making sure that they're protected by a surge protection device. Let's talk about service disconnects. Now, for 1 or 2 family dwellings, service disconnects must be installed outdoors. So this is something new. It used to not require it to be outdoors or mandated to be outdoors. And it can be outdoors on that dwelling or in sight of the dwelling in accordance with that one paragraph there. Other than 1 or 2 family dwellings, they say that it can be outside or at the point nearest, the entrance nearest the point of entry of the service conductors. So they're just trying to make sure that in the case of a fire or something, that they have quick access. There's no confusion about how to turn that power off and where it's located, so they can quickly find it. Certainly understandable. So another way that they've deemed necessary, they really want to be able to find that service disconnect. So what they're mandating now, that on 1 and 2 family homes, that you will have the outside of that enclosure clearly marked in a red label with white lettering saying this is where your emergency disconnect is. And then once you open up that cover, right next to that disconnect switch, you will have another notification that says this is your service disconnect. So trying to make things very clear for anybody arriving to a 1 or 2 family home. Electric vehicles and the powering of electric vehicles and charging them up. So this does not apply to 1 or 2 family dwellings. This is where to facilities that charge up multiple electrical vehicles. And they're really looking for an emergency shutoff. They want that emergency, and they go into details here in the paragraphs talking about where they want it located. They just want to make sure they can quickly turn off power in case there's a problem. You know, they want to no more than 20 feet to the actual location of the vehicles being charged up, and no more than 100 feet within line of sight. And it will be clearly marked. So good idea. I guess this is part of the evolution of electric vehicles becoming more and more of a presence here in the States. And the last one I think I have here is just another paragraph that was modified. 3 sections. There's 3 things that they added. They want to make sure that you're using a listed type inlet. I guess inlet, right? Yeah, outlet. No, it's outlet. And that you don't have a 50 amp rated receptacle supplied by a 40 amp branch circuit, and their locking pin and sleeve are now allowed. And I guess it's probably easier if we just look at that complete paragraph. So here's how that paragraph looked in 2023 and how it looks in 2026 with those 3 things that I just mentioned outlined as changes. All right, so in summary here, so we talked about our learning objectives. We went over the NFPA code making process. We dwelled down into those 4 electrical systems that require backup power or power transfer. We talked about the extensive changes that were made in the 2026 NEC. Obviously, there's thousands of them. We only touched on a few, so if you're interested or concerned, you got to get that code in your hands, and you got to go through it. So I hope this was beneficial to everybody. And now I guess, Catherine, I guess we're ready to open up for questions. If anybody has any questions, and this is your chance to stump the presenter, and I'm sure you could do it if you really wanted to. So go ahead.
Yeah, so far, thank you, Robert. So far we have a couple questions. So first, I thought fire pump safety was life safety, not legally required.
Fire pumps was life safety and not legally required. I don't. Oh, that's a good one. You'd have to go back. I'd have to go back and look, but I'm pretty sure it's legally required. Yeah, I'd have to go back and look. That's a good one. I always assumed it was legally required. We have to look at the wording in the code.
Okay, and then next question, 700.6D item 3 states that if the bypass equipment is manual or non-automatic, it shall be actively supervised while the automatic transfer equipment is disabled for servicing. Is it possible to avoid the supervision with design or installation provisions? Can the bypass be automatic?
Yeah, there are ways to get around that transfer switch and make it be automatic. I know there's people who make transfer switches that do have both automatic bypass as well as an automatic transfer switch. Um, but you have to think is what is the not to discount that, but what is the likelihood that you're actually bypassing a transfer switch? The only time you actually would probably do that is if that transfer switch failed. And if you look at the life expectancy on a transfer switch, a good one that's made by reputable companies, they last forever. I mean, this is a critical part of your electrical system, and you can't afford for that to be made cheaply. You want to spend whatever it takes to get a good one. But you're right. If it does go down or it does need to be serviced or repaired, you need to bypass it. So when it's bypassed, what you're doing is saying, okay, normal power, I want to make sure you're supplying my loads. So what are the chances that you're actually going to lose power in that time frame you're bypassed? Not likely to happen. But if it is a manual switch, you're still required in an emergency system to switch over to backup power within 10 seconds. So you would have to have somebody there. I hope that addressed your question.
Okay. The
Yes.
next question, does anyone make a fire pump temp connection?
I don't really know. I know ASCO does not. Um, yeah, I'm not sure.
The next question also is fire pump. Does anyone make BIS rated fire pump ATS?
All these fire pump questions. This is not my wheelhouse. So yeah, I have to be honest and say I have no idea. Can't help you there.
Okay, does anybody else have any other additional questions?
Well, you did a good job of stumping the presenter because he went to an area that I was not knowledgeable on. So. All right.
That's all I see. If you think of any questions, feel free to reach out and we can always forward them on to Robert. But thank you so much, Robert, and thank you all for joining us. We really appreciate your time. Be sure to come. Oh, wait, here's one more question. Sorry. The permanent generator is separately derived and ATS is 4-pole. Does the docking station slash MTS need to be 4-pole? How would the temp generator be grounded?
Yeah, they should have a grounding rod at the location where that temporary generator would be hooked up. And yeah, it would need to be a 4-pole. Yep.
Okay. Any other questions?
All right. Very good.
Let's see. So thank you again. Thank you all for joining us, and thank you, Robert. That's a great presentation.
All right. Thank you. Take care.